We have just finished the scan of this side skirt part of a car using our FreeScan combo. We are gonna now let the software process the mesh, and we are going to directly open this part in the EXModel in order to carry out its reverse engineering. So watch this video if you want to see how to do it in a detailed step-by-step tutorial. After exporting the scan data from FreeScan software to EXModel, the mesh displays in its interface. Let's take a look at the part. It consists of a freeform shape, okay, plus some prismatic geometries here and there. So we are going to split this reverse engineering into two works. The first one would be the surfacing, and afterwards we are going to finish the reverse engineering with the design of these two features here. Before that, let's save our project. And let's align it to the coordinate system, because right now it is aligned to the scanner coordinate system. To do so, we go to extract primitives, and we are going to extract features from the geometry. In this case, I'm selecting some triangles corresponding to this edge to best fit a plane. I just need some of them. I don't need to select the entire edge. And I'm going to click on Create and Stay to create another plane on this surface here, repeating the process of selecting some triangles. Perfect. Create and Stay. And finally, let's best fit a plane here. We can use the magic wand. And we exit the tool because we have enough features now to align the mesh to the coordinate system. So we go to Align and the first option, and we choose the three planes that we have generated and select the orientation desired. Actually, this one, yeah. This looks good. The orientation desired for our part. Click on Apply, Close, and now the part is aligned to the EXModel coordinate system. Right, we can delete these planes. We don't need them anymore. And we proceed with the surfacing task. To do it, we are going to create a new freeform, and we are going to make sure that the snap mode is on. We start drawing one small face over here. And personally, I prefer work with the tolerance options on, in this case with a value of 0.25 millimeters. And we are gonna extend, let's adjust it a little bit. We are gonna extend this face, creating new faces to cover the surface of this mesh. Okay. To extend an edge, you can double click on it. It turns yellow, and then with the D handle, you can extend the surface. Now, if you observe some unexpected high error like this, it's because the surface is snapping on the other side of the mesh. So you can simply correct it by moving it a little bit, and it will snap onto the proper surface. Let's extend this one here a little bit more. Actually, let's move the entire edge, and let's extrude it once more, like this, and let's correct these snapping problems manually. Just in case we move this one. That's it. Okay, now let's continue, but on the other side. We select the entire edge and we extrude it with the D handle. We have the same problem of snapping, but we can easily correct it like this. and we continue our work. Here I'm doing shorter faces because the curvature is higher on this point of the mesh. And it's a matter of selecting the edge, extruding it, letting it snapping onto the mesh, and repeating. Of course, correcting at each iteration if necessary. Well done. Another short face. Good. And now that the mesh transitions to a smoother shape, we can do a little bit longer faces. Okay. In any case, at this point, I observe that on these regions here and here, I'm accumulating too much error. So this is maybe indicating me that I need more resolution, especially in this vertical direction. So I select the edge and I split this face here. And now I have high resolution and I can adjust my surface accordingly to minimize these errors. Actually, we are going to split this face here as well and move the edge here to minimize the error. Okay, this looks quite good. And now, instead of extruding more and more and more faces, we are going to extrapolate the current surface that we have. So we click on here and we select the edge and we extrapolate it. Okay, now we have points, vertices of this surface that are onto the mesh and points that are not onto the mesh, right? So let's first take care of the points that are onto the mesh. We go to the manipulate, and with the snap mode on, we move them a little bit and let them snap onto the mesh to give us, well, a surface that adjusts well to the mesh. Okay, this looks good. However, because these points are not onto the mesh, we cannot snap them onto the mesh, right? So we turn the snap mode off, we click on one of them, and we make sure that the manipulator is set to local instead of world or screen to local. Now, we select these points here and we start, or edges, and we start manipulating the surface to make it fit onto the mesh. Okay, this requires a bit of patience and working slowly until we can, oops, that was definitely too much, until we reproduce the shape of this surface. Okay, for this one, we are gonna need to move it a little bit upwards. This looks better. And we can correct also these points here and there, trying to find this green color right onto the mesh, meaning that the surface is adjusting well onto the surface. Oh, sorry, onto the mesh. Actually, that one is good like this. Okay, and once we are satisfied with the result, let's extrapolate the surface but on this opposite direction and do the same here on this side. Let's extrapolate it till here. Let's actually give it some extra resolution there. Sorry, let's select Edit, Manipulate, click on this edge and split this face. And now update the view. First, with the snap mode on, we can adjust the points that are onto the mesh, like these ones. And now for the points that are not onto the mesh, we turn it off and we adjust them manually. Actually, let's move the entire edge to the left, like this. And little by little, let's adjust this freeform so it more or less has it follows the shape of the original mesh. Okay, let's move this one a little bit to the left. So it's a bit more relaxed. And then let's adjust this edge here, maybe a little bit upwards until we acquire or we achieve a mesh that fits well. Well, not a mesh, but a surface that fits well onto the mesh. This might need some time, patience, experience, I would say as well. But in the end, it's a matter of trying and try and error. Okay, I'm quite satisfied with the result now. And before continuing, so now the surface is adjusting quite well onto the mesh, but let's check the surface quality with the zebra stripes. And what we have to pay attention to here is that these zebra stripes move smoothly onto the surface. And to improve it, what we can do is giving it some clicks here on the smooth tool, and by compromising the smoothness, well, not the smoothness, but the tolerance a little bit, we obtain a better surface quality. Okay, so with that, I believe we have obtained a really nice surface, and let's extrapolate it towards the side in order to cover it completely. And with that, we are done with the first freeform. Now, what's next? We are gonna reproduce this freeform here and also this freeform there. So I'm gonna turn this one off and create a new freeform here on this side. Make sure that the snap mode is on, and let's create our first face. There we go. Update the view, and with the D handle we extend it. That's it. Extend, correct, and continue. Okay, that was fast. Again, we can smooth it a little bit to have a better surface quality. And click on close. And we said, before that, remember to extrapolate always the surface beyond the surface of the mesh that we are reproducing, like this. And now let's do the same here. New freeform, snap mode is on. We fit or we snap this face here. And little by little, we reproduce the surface. Like this. Now here we have definitely too much error, so what we can do is splitting this face to have some extra resolution, and now adjust the surface a little bit more. Like this, and actually we could even give it some extra resolution here. Oh, actually that looks quite nice. And let's make it a little bit smoother to improve the surface quality. And I forgot again. Let's extrapolate it beyond the surface. Okay, that looks good. Click on close, and now observe the result. What we have here is freeforms that reproduce the outer shape of the mesh. However, we need to give it certain thickness, right? And how we are going to do it is with the offset tool. So click on the surface, go to the surfacing menu, and here you have the option thicken/offset, which is grayed out now. But you can solve that by simply clicking on choose surface once, and now you can carry out this operation. Now, we are going to try different values of thickness. Actually, it's extruding to the other side, you will notice now. So we have to invert this extrusion. And 3 looks like a good result. Let's try with 3.5, which might be too much. Maybe something in between 3.25 adjusts well. We are going to use this value. And this result is a solid. So because we are doing the surfacing, we want to work with surfaces. And I want to disable, therefore, this checkbox here. Click on OK. And we have our first thickness, right? So repeat the process with this one. We have to sew the surface first, and we're going to give it certain thickness. To the other side, 3.25 with no thickness. Actually, this one might be a little bit thicker. Let's try with 3.5. Okay, let's use this value. And finally, we do the same with this one here. Let's first try 3.25 to this direction and surfaces, and it adjusts quite well. So click on OK. And now, okay, we have the surfaces that are going to give us, when properly trimmed, the resulting solid, but we need to first of all create the features that we are going to use to trim them, right? So let's do it. Let's hide all of them first. And first thing I realize is that I need to trim them here on this side, which actually corresponds to the first plane that we used to align the mesh to the coordinate system. So instead of extracting a plane, let's simply construct it. We select the plane, this orientation at offset 0, meaning on the origin, and let's adjust its size a little bit. Right? We have our nice plane here cutting actually my surfaces. Nice. Okay, what else do we need? We need another plane here. This one, we will extract it. We simply select some triangles corresponding to this face, and we are gonna best fit a plane there. Plane. There we go. We also gonna need a plane here, so let's extract another plane on this face. Create. Let's extend it so it cuts the other planes. Cool. Now, for this geometry here, the way to approach it is by extruding a sketch, an open sketch, to obtain a surface. So let's do it. Click on 2D sketch, select the proper orientation, and the first thing that we observe is that when moving this plane, we are not able to slice on the position that would work well for us to extract this information, right? So I'm going to show you a trick. Simply go to Stack Sections and move this volume until you compress all these 20 sections on the region of interest. So you have all the information here with a lot of density, and therefore you can clearly see how the result that you were looking for. Now, what we do is let's start here in the origin. Let's draw a horizontal line like this. Actually, let's click on it and make sure that it's horizontal. And now let's reproduce this geometry. How? Well, with the Shift key and selecting the points, you can quickly best fit lines. Here, actually, I will eyeball one horizontal line on the top of this shape. Here, let's also best fit a line, like so. Let's extend it a little bit more. And to close it here, let's extend this line. We are going to trim it afterwards. And here we can do the same. Let's best fit a line here. That looks good. And for this shape, let's do it later. Let's finish the process with a horizontal line over here. Good. Now, to close it, we add a spline. We're gonna use 2 control points and close it with the endpoints of these lines. Now, because we want a smooth transition, let's make them tangents. So select first the spline and then one of the lines and click on the tangency constraint. And do the same here. Spline, line, tangent. Now you can use the control points to adjust the spline accordingly. And you will get a very nice result. That's it. Okay, let's extend this line a little bit more. And also, let's draw a little bit more of line here. This is going to help us having a larger surface eventually. And for this, we have to close these endpoints. First of all, let's trim this line. There we go. And now with the Control key and the mouse, you can select both endpoints and the software will close the lines at the intersection. This fillet, we can do it afterwards. We are not going to do it now. Okay, click on OK. The result is, of course, an open sketch. And if you extrude it, you will obtain a surface like this. That looks good. We have here our surface. And let's see what's left. So our surfaces will close here. They will close here, here as well. Oh, we need to reproduce this shape here, this face here, to close these 2 surfaces. And this we are going to do it with a freeform. So again, let's hide everything, also the planes. And you know the process. We create quickly a new face here, update the view, and extend it. Always snapping on the mesh. I'm going to move it till the end, and I'm going to split this one like this and adjust it a little bit more. Perfect. Now, let's resolve this error here. Perfect. Now, let's make it a little bit smoother, and let's extrapolate it. There we go. Close, display all the surfaces and planes. And now we have all the surfaces and planes, all the features, to close solid, and so obtaining the shell of the mesh, which is going to result in a solid body. And in order to obtain that, let's hide the mesh. Let's select all the surfaces, and we are going to click on this small button over here, which is trim. Now the software will need some time to compute all the intersections between all the surfaces, and we are gonna continue later. Okay, the software has finished calculating all the intersections between all the surfaces and planes, and now our goal is to remove all the regions that do not correspond to the shell of the object that we want to obtain. So the way to do it is simply deleting those regions that do not belong to the object itself. Yeah, we can start with the surfaces that we clearly see that do not correspond to the object, and this way we are going to also clearly see what actions or what surfaces need to be trimmed. So I'm very quickly clicking on the surfaces that do not correspond to the object. If you need it, you can turn the mesh on, and this way you have maybe a better vision of how or of which surfaces do not belong to the object. Right now I'm tackling the surfaces that are bigger or larger, yes. And these small ones over here. Let's tackle this region and clean it up. This looks quite good. This looks good. We have this small one here, which actually is deleting unexpectedly the entire surface. Okay, it's not cutting well with this plane here on the left. Well, this is something that can happen, but it's nothing to really worry about because we can take care of it afterwards at a later stage. Anyways, let's hide the mesh. Let's make sure that everything is cut well. Here we have these remaining surfaces. And now, although it might look like we have completed the task, there are some regions that we still need to delete, but that are not visible right now. So that's why we have this visibility panel here on the left. It allows us to hide some of the surfaces, and at the same time, it allows us to see through them and find regions like these ones here that need to be deleted. Okay, so we are going to check that everything is correct by hiding the surfaces one by one. Now, something we need to pay attention to is this kind of surface we have here. So this surface here, this dark purple brown surface here on the top, is going inside the volume of the solid. You can see it here. So we need to pay a lot of attention and make sure that we delete such faces. Otherwise, the surfaces intersect with the volume of the solid, and eventually we are not going to obtain an empty shell, which is going to become a solid. Rather, we are going to obtain a surface, and this is something that we don't want. So this step is crucial and requires a lot of attention, and that's why we need to invest some time in checking this issue. So I've hidden this plane now. Let's hide this other one, the offset surface, and check here. Maybe you see it better from the other side, that this yellowish surface is again going inside the volume of the body. So we need to delete this one, right? This is what we are looking for. This is a source of problems, so we need to pay a lot of attention to them. Okay, let's continue. Hide this one. Everything looks fine here. Looking good here. And now let's turn them on one by one and check them again. Here we have exactly the same problem that we described. The surface on the left is going into the volume of the solid, so delete these faces. Okay, this looks clear. This plane Looks good, no problems with it. The offset surface, watch out, it's going into the volume, so we need to delete this region. The plane here is well defined and well trimmed. Same for this offset. And well, we have this extruded surface, which unfortunately leads to this problem, right? But we are going to solve it now. So far, everything looks good. Okay, we have no intersections here. Everything looks good. So we can click on OK and check the results so far. This operation of trimming might take a little bit to process. Okay, the software has finished computing the trimming operation, and now we see that we not only have this small portion here, we also have this big plane there, so we need to solve that. Let's select both of them again and click again on the trim operation. Now click on the plane to make rid of it. Okay, and let's try to trim this one here. And what I observe is that unfortunately not only this small portion but also the entire surface here has been deleted, which is unfortunate, but we can deal with that. So let's accept the operation. And as you can see, we have all the surfaces stitching together, becoming the outer shell of our solid, except for this hole that has been left here on the top. And to solve it, we go to Surfacing, Fill Surface. We pick one of the boundaries, and the software automatically detects all the contacts of this surface. And as soon as I click on OK, and the surface is attached, the software recognizes that all these surfaces intersect with each other, enclosing an empty volume, and therefore it becomes, as you can see here, a solid. Let's take a look at the comparison with the mesh. We can observe the result so far, and this would be the end of the surfacing task. Let's now continue with the other part of this reverse engineering, which is designing these two features over here. And to do it, we start with a 2D sketch. We select the proper orientation, and we cut our mesh, or we slice it at a position that gives us the information that we need. Make sure that the Create Sketch on Slicing Plane is enabled for this case. We click on Create, and we start by best fitting a couple of lines here and there. We are going to extrude them. Well, we are going to extend them, sorry. And we are going to create a horizontal line on the origin of the coordinate system. And let's now join these endpoints. Now on this side, we are going to draw a small line following this angle here. And we join these endpoints, and we even do the filleting. And now we can extend these lines a little bit more and connect them together. That's it. Click on OK. And now we have a closed sketch that we can extrude and obtain a solid. Now, with the mesh displayed and the sniping tool on, we can select directly on the mesh what's the extension of this extrusion. And we are going to use these two walls here. Make sure that new solid is selected and click on OK. Now we have our basic solid, and we are going to tackle now the cuttings. To do the cuttings, we repeat the process. We create another sketch, also in this position, so I have enough information. And again, making sure that Create Sketch on Slicing Plane is selected. click on create, and now we focus on the inner walls of this solid. This one here, maybe we can, I believe it's going to be easier if we simply do a horizontal line and we connect the endpoints. Like this. And let's extend these two lines beyond the origin and close the sketch. Let's repeat the process and let's extend till the inner wall, right? Now, on this side here, we are gonna simplify the model for the sake of the demo. So we are gonna simply do the whole till here. New solid is again selected and click on OK. And now let's focus on this cutting over here. For this, again, we repeat the process. We select the proper plane and we move the slicing plane accordingly. Great. Again, create sketch and slicing plane is selected. And we best fit these three lines here. We join them. We fillet them. And let's extend these lines beyond this body and close the sketch. All right, now we extrude this closed sketch till certain height here, and here making sure that it extrudes until it's inside the other body. New solid is again selected, click on OK. And now let's focus on this square shape hole over here. And again, we repeat the process, this plane. We try to find a suitable position for it. There we go. Click on create and let's eyeball a rectangle over here. Well, this is parametric design, so of course you can use all the constraints. You can also give dimensions to your sketches, right? So you have all the control over the design as you might be used to. Well, let's make this one a little bit longer and let's extrude this sketch. Again, select the sketch, click extrusion, make sure that it goes inside the body on one of the directions, and for the other one we extend it till certain length. New solid, is again selected, click on OK. And now we have these three bodies that we have to cut from this basic body, right? So the first thing we do is combining them together with the Control key and selecting all the three of them. We can click then on Combine Selected Solids. Now we have obtained only one solid, as you can see here. We display the basic solid. We click on it and we choose the option Cut from Selected Solid. Now we tell the software which solid has to be used to carry out the cut operation, and we obtain the result. Click on OK. And this is how it's gonna look like. However, we have to cut now this portion of the initial solid, right, before merging these two solids. So let's do it. Let's try with a plane on this position. And okay, let's now draw a rectangle . Actually, let's display first of all the previous sketches that we used. There we go. There we go. And what we are going to do, using these sketches as reference, we are going to design this rectangle over here, making sure that we cut enough material from the other solid. Click on OK. Select the rectangle, and let's extrude it until it goes here inside the walls of the new solid that we have designed. And likewise here. New solid is again selected. Click on OK. And now we choose this solid, and we tell the software that we want to cut this solid with this one. There we go. Now we are good to select both solids with the Control key and combine them together. Let's hide these sketches. And now let's focus on this other shape here. The process, as you might expect, is the same. Just create the 2D plane on and place this slicing plane on a suitable position. Create sketch on slicing plane is selected. Click on create. And now we draw a sketch trying to reproduce the shape of our original body. I'm going to make a horizontal line here, and let's best fit lines here and there. Actually, yeah, this is a line, perfect. And let's do the same with all this long line here. This looks quite good. Let's select more points. That's it. Okay, and now let's close the sketch. With the Control key, remember, you can connect two endpoints easily. Here, let's assume that we can ignore this deformed shape of the mesh. Now let's extend this line, making sure that it goes inside the shape of the body. And let's also extend this other one, but paying attention not to overcome, not to go beyond the geometry of the original object. So we are going to move a little bit to the inside and then connect the two endpoints. Here I can see that they appear orange, so let's make sure they are connected. Now this is a closed sketch. Click on OK. Let's extrude it, let's display the mesh, and let's snap on these walls to define the extension of this extrusion. New solid is selected, click on OK. Let's hide the mesh, let's observe the result. Actually, I could correct my sketch a bit because the solid goes beyond, right? It's too large and it goes beyond the original body. So let's correct this. We double click on the sketch and we edit a little bit this line here, and now it's inside the body. So now we can choose both solids, combine them together, and that would be how we reproduce these prismatic shapes. And before completing the process, well, if we take a look at the comparison, we observe some errors here, right here, over there too, here as well. Well, the fillets are missing, and this is the last operation we would carry out. So to do it, just select the surface and click on fillet, and now you should be able to select the edge. And I recommend you to use the tolerance tool here. With it, you start dragging this arrow, and you can see live how the tolerances result evolves as you change the value of this filleting. Right now, we start to see our green color. So let's try with a 6mm radius for this fillet and click on OK. There we go. And we simply repeat the process with all the edges that need filleting. Let's see if we can use the same value. No, here we require a smaller value definitely. So let's start with 1 and let's increase it a little bit more. Yeah, I believe that we can use a value of 4. Okay. And let's do the same on this side. Let's drag this arrow. Hold on. Let's choose it. Let's select it again. Display the mesh. Let's drag the arrow. Yeah, let's try with 4. Apply. And actually, let's use the same value here on this side. 4, apply. Maybe a little bit more. Let's use the 6mm. Okay. And as promised, let's finish the work with this small filleting here. And let's use a value of 3.5, for instance. Click on OK. And now our job is done. Let's observe the color map of the error. And this is how we have obtained a solid body that we can export in STEP, for instance, or in any CAD file format, and that accurately reproduces the solid that we have scanned.